All right, this time I want to talk about algebra. Algebra proficiency is the biggest stumbling block that many students have to just thinking about the physics. If you're not comfortable with the math, you can't think about the physics. So I want to talk a little bit about the kind of math that you're expected to be proficient at, not just able to do after you think about it, but able to bust it out without any difficulty. And that's why we're reviewing it now. We've already talked about, or if you're watching these in a different order, maybe not, but the position equation for kinematics is a quadratic. That means there are cases where we might have to use the quadratic formula to find time. I'm tempted at this point to complete the square to derive the quadratic formula, but I will leave that for another time. You don't really need that for this course, but you may use that in a later physics course if you're doing something a little more complicated and using some type of conic section. If you're interested, you can ask me and I'll do that for you. All right, but if we just take the quadratic formula at face value, this is our standard form for a quadratic. This is the form that you would be in to complete the square to solve for the quadratic formula. If I solve this for x, I get negative b plus or minus the square root b squared minus 4ac all over 2a. So we need to be able to look at our position equation, plug in some numbers, and solve for time. So what are we actually looking at here? Let's assume that, what do I want to do? Let's throw something in the air. So I'm going to have an initial velocity of 5 meters per second. We're going to throw it from the top of a roof. So I'm going to have an initial height of, let's say, 3 meters. And acceleration will be minus 9.8 meters per second squared. And final height will be 0 because it's going to hit the ground. Right, so there's a guy standing here. He throws a ball in the air. It goes down and hits the ground. Right, we're not concerned with the physics right now. We're looking at the math, but this is a realistic situation that you could try to solve. So if I look at this, I've got 0 equal to 3 meters plus 5 meters per second times time plus 1/2 minus 9.8 meters per second squared times squared. All right, so it's interesting at this point to look at the units. We've got meters, meters per second times seconds, which gives us meters, and meters per second squared times second squared, which gives us meters. So our units work out, which is always important in physics. But again, we're just looking at math. So let's just write this mathy. We'll get rid of our units. All right. Now that looks like our quadratic equation in standard form, or any quadratic equation in standard form. And now we'll use our quadratic formula. Right? The thing to remember with the quadratic formula, the way we wrote it was, I'll just write it again, ax squared plus bx plus c equals 0. Your quadratic term, your degree 2 term, is the a. Your degree 1 term or linear term is the b. And then your constant term is the c. So when we write our quadratic formula, and our variable is t in this case, not x. So we have t is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And now we're going to plug in our numbers. So t is equal to, b in this case is 5. 5 squared is 25. 4. A is minus 4.9. And C is 3. 2A is minus 9.8. Important to keep an eye on your signs there. In general, we're looking for positive values of time. And if you were to mess up your sign in your denominator here, then you might take the wrong sign on top, right? And get the wrong value. So it's important to watch your signs here. So how long would it take this to reach the ground? We can just plug in those numbers. That's 5 plus or minus the square root. Let's see, 25 minus 4 times negative 4.9 times 3 is 83.8. All right, the square root of that's going to be more than 9, right? Because 81 is 9 squared. So if I were to take the positive one here, I would get a positive value, and when I divide by this, I would get negative. So we're going to select the negative result. We can do both, right? I'll just do both. Positive result, negative result. The positive result, let me square root that answer. Minus 5, 5, negative 9.8 is going to give us minus 0.424 seconds. If we do the other way, square root a 3.8, and we take the negative result there, so they will then add together because we have negative 5. .44 seconds. So that's why I said we wanted to take the negative option here to get us a positive time. If we were to look back at our drawing, what we have solved for is when it hits the ground, right? But you can trace this line back, and there's an imaginary point here where it was on the ground, moving upward to move through this path. That's what that negative time represents. Something that didn't really happen. But mathematically, the only condition we've set is that we're at a height of 0. And mathematically, both of those are valid. But if we look at the physics, only one of those makes sense. All right, so that's the quadratic formula. We also just want to be comfortable with rearranging things in algebra and solving systems of equations. So let's look at a system of equations you might run into. I got to think about what the other equation would look like in this case. All right. This is a real physical situation that we'll do. It's related to an Atwood's machine, but this is a system of equations. And we're going to solve for A. In terms of G, M1, and M2. So that means that we have to eliminate T. So there are a couple of options if we want to eliminate T. For this particular equation, you can see that it would be pretty straightforward to add the equations. So if I call this equation 1 and equation 2, I can take equation 1 and equation 2, and I can add the left-hand sides and add the right-hand sides. If this is equal to this, and this is equal to this, then if I add both left-hand sides and I add both right-hand sides, they still have to be equal. So if we look at the left-hand side, you see that you have a positive t and a negative t. So we're going to end up with m2g minus m1g. And on the right-hand side, we'll have m1a plus m2a. And we've eliminated t, but we haven't yet solved for a. So if we want to solve for a, the first thing we do is get all the terms with a on one side, which is done for us. And then we're going to factor out the a. We could factor g on the other side if we want to. And then to solve for a, we're going to divide. So we have g times m2 minus m1 over m1 plus m2. So this would be adding to eliminate. We can also do substitution. So let's work through this same equation in substitution. Let's see, we had t minus m1g equal to m1a, and we had m2g minus t equal to m2a. This time, for substitution, I'm going to solve one equation for t and then plug it into the other equation to get rid of it. So solve for t. So I can do that by adding m1g to both sides. So t is m1a and m1g. Now I know what t looks like. So I can plug this in for t in the other equation. Or substitute. Right. So now I've got M2G minus M1G plus M1A equal to M2A. Distribute my negative sign. The next thing we need to do is get all of our A's on one side. So we'll add M1A to both sides. And we're back to the same point we were in the other equation. We end up with A equal to G times M2 minus M1 over M1 plus M2. All right. So we have reviewed the quadratic formula and we've looked at solving by elimination and substitution. One more thing I want to do is consider a ratio. You may end up where you have sine theta equal to something, we'll call it A, and cosine theta equal to something, we'll call it B. And these are some numbers that you know, and you want to know what those are. You can do inverse trig functions and get numbers and plug them in, and you're taking like the sine of the cosine inverse of a bunch of numbers. Or we can set up a ratio in the same way that if I add the left-hand sides and I add the right-hand sides, they're still equal. If I divide equation 1 by equation 2 on the left-hand side and the right-hand side, they're still equal, as long as there are no zeros, right? I can't divide by 0. So I can then say that sine theta over cosine theta is equal to A over B. But we know that sine theta over cosine theta is tangent theta. And that makes that an easy calculation, right? So I would say that would be the last common technique for solving a system of equations here. And I'm going to stop there before this gets too long. I could do just some general rearranging with algebra, but we did a little bit of that in order to solve our systems.